Good day, everyone. What we are going to discuss this day is all about frequency distribution. So, a frequency distribution is a statistical tool used to show the number of count of occurrences or observations in different categories or classes in a data set. It is an organized way of presenting information about the distribution or about the spread of data. Ito ay ginagamit para makita natin ang summary or yung overview ng data sa pamagitan ng pagkuha ng bilang o number of occurrences para sa bawat category or class. We can also create visualization like bar charts, histograms, or pie chart, etc. that present data in a clearer and more easily understandable manner. We can also identify patterns or trends in the data based on its distribution. We can make comparison between classes or categories in the data on which group have higher and lower number of occurrences. And lastly, it will also allow us to calculate various statistics such as mean, median, and mode for the data set. So generally, when we talk about frequency distribution, it is an important step in the analysis and interpretation of data. It reveals patterns, facilitate comparisons, and suggests potential trends that can be helpful in decision making, research, or analysis in various fields such as science, engineering, education, economics, or sociology, etc. So, our main learning objectives for today's session is to construct a frequency distribution for a given data set, prepare for a frequency distribution table, graph the frequency histograms, polygons, and ogives, and draw the relative frequency for or percentage frequencies and interpret the result of the graph. So let's start constructing a frequency distribution for a given data set. But before that, to make it clearer, when we say frequency distribution, it is a tabulation or grouping of data into appropriate categories, showing the number of observation in each group or in each category. In the sample table, this only shows the raw data which represents the score of students in engineering and data analysis class. And this data solely comprises of unprocessed score of students. And to derive meaningful insights from this data or from this raw data or unprocessed data, our next step involves the creation of a frequency distribution table for us to make sense of this data. But before creating a frequency distribution, let us know first the elements, the parts of the frequency table. One here is the class limits. It refers to the groupings or categories defined by lower and upper limits. So say for example, 16 to 20, 21 to 25, 26 to 30. So when we talk about class limits, our keyword here is actually the lower and the upper limits. So in our example, we have 16 to 20. 16 here is the lower limit and 20 is the upper limit. Okay, 21 to 25. 21 is the lower limit. 25 is the upper limit. Same for 26 to 30. 26 is the lower limit. 30 is the upper limit. So the lower class limits are the smallest numbers, no, that belong to the different classes, and the upper class limits refers to the highest number that belongs to the different classes. So class limits, the second one is class size. So class size, by definition, it is the width of each class interval. So, say for example, in our case, a while ago, we have here our class limits, which is defined by the lower, the upper class limits. So when we are going to scrutinize, no, the width of this, of each of the class interval, no, we have a class size of 5. Now, how do we get that? So 16, so the next plus 5, uh, 16 plus 5 would definitely give us 21 plus 5, that will give us 26. So 16, 21 to 26. So that means the class size, no, our class size is 5. Even if we are going to scrutinize also the difference, no, of the values in the upper limits. So we have 20 plus 5, we have 25 plus 5, we will be able to get 30. So again, the class width or the class size here is 5. The third one is class boundaries. These are numbers used to separate class but without gaps created by class limits. The number to be added or subtracted is half the difference between the upper class limit of one class and the lower limit of the next class. So again, this is what we call as class boundaries. And our class boundaries can be determined, no, by definitely adding or subtracting the half of the difference between the upper limit of one class and the lower limit of the next class. So, say for example, we have here our upper limit, which is 20, and the lower limit of the next class is 21. So 21 minus 20, definitely we will be able to come up with 1. What is stated here is half of the difference. So that means this is, we are going to divide it into 2. That is actually equal to 0.5. 1/2 or 0.5. This is the value that we are going to add and subtract from the upper and the lower limit. So that means 16. Okay, on the part of the lower limit, so we are going to subtract it. So 16 minus 0.5, definitely we have 15.5. 21 minus 0.5, we have 20.5. And 26 minus 0.5, we have 25.5, and 31 minus 0.5, we have 30.5. On the upper class boundary, we are going to add the other half. So that is actually 20 plus 0.5, we have 20.5, then 25.5, this is 30.5, and 35. So this is our class boundaries, no? Next is, of course, no? Class limits, class size, class boundaries, and then class marks. When we say class marks, these are midpoints of the lower and upper class limits. They can be found by adding the lower and upper limits and then divide by 2. So, say for example, na, same example, then we have here a class interval, 16 to 20, 21 to 25, 26 to 30, and 31 to 34. So, our class marks are midpoints, no, of the upper and lower class limits. What we are going to do is to add, no, the lower and the upper limits, then we are going to divide it by 2. So 16 plus 20, we are going to get 36. No? Divided by 2, this will give us 18. Then 21 plus 25, this will give us 46. And divided by 2, we have 23. 23. 26 divided by 26 plus 30, that is 56 divided by 2, then that will give us 28. And 31 plus 35, that is 66, divide 2, this will give us 30. So this is our class mark. No? Do not forget on how are we going to calculate the class mark. We are going to look for the midpoints of the lower and upper class limits by adding the lower and upper limits and then divide by 2. Next step is to construct a frequency distribution table. So let us still use, no, the sample scorers, no, of the students in the class. So our steps here is, first, we are going to find the range, determine the class width, set up the class limits of each class, set up class boundaries, tally the scores, and solve the class mark or midpoint of each class. So in finding the range, we have to take note that we are going to arrange the scores lowest to highest for us to be able to determine what would be the highest score and what would be the lowest score. Because in finding the range is equals to, okay, in finding the range, we have R is equals to the highest score minus the lowest score. So if we are going to look into the table, ayan, so we are going to look it one by one. So in this case, we will be able to get, no, that the highest score now is no other than 19. 19. And the lowest score here is, of course, we have 2. Okay. So in that case, we have, so 19 minus 2, and our range is actually 17. So next step is determining the class width. So in determining the class width, what we are going to do is to divide the range by the desired number of groupings. And the class size, take note, is the width of its class interval. So in finding the class width, we have here our formula. C is equals range over the desired number of class intervals. And another way for us to look for the number of class intervals is by using the Storz formula. And the Storz formula is defined by K is equals to 1 plus 3.3 log n, where K is the number of class intervals and n is the total number of observations. So in our example here, we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a total of 60 scores. So we have 60 number of observations. So in finding the number of class intervals, so we have to substitute the value 1 plus 3.33 log 60. So we have 1 plus 3.3 log 60 is, okay, using our calculator, that is 1.77815. So definitely in that case, we have our K, no? Which is, if we are going to simplify 1 plus 3.3 times 1.77815, then our K here is 6.867. Or that is approximately, no? If we're going to round it up to the nearest whole number, then we have 7 as our class interval. So definitely in computing the class width, so we have C, no? Is equals to, what would be our range? 17 divided by the number of class intervals, which is 7. Therefore, 17 divided by 7, that will give us 2.42. And so if we are going to round it up to the nearest whole number, then we have our class width, which is more or less 3. Okay? So take note, our range is 17, and our class width here right now is 3. So next step that we're going to do is, so again, our range is 17. This would be our range. Our class width is 3. So the next step that we're going to do here is set up the class limits of its class. We have to take note that the limits of each class are defined by the lower limit and the upper limit. And the highest observed value should be part of the highest class interval, and the lowest observed value should be part of the lowest class interval. So in that case, our lowest score is 2 and our highest score is 19. So in making a class interval, so we have, so say for example, this is our CI, which is defined by lower limit and the upper limit. So we have 2, no? And our class width is 3, so 2 plus 3, we have 5. And the next plus 3, 8. And then plus 3, we have 11. Plus 3, we have 14. Plus 3, we have 17. So we have 1, 2, 3, 4, 5, 6. Okay. And this is our lower limit. Our upper limit is 2, 3, of course, no? We have 3, no? As our class width. So 2, 3, 4. Yeah. 4 plus 3 is 7. 8. 7 plus 3, we have 10. Plus 3, we have 13. Plus 3, we have 16. And plus 3, we have 19. Okay. So this is our class limits now. So we have here our lower limits and we have here our upper limits. So next step that we are going to do is to set up class boundaries. So class boundaries. So how are we going to set up class boundaries? We are going to add and subtract the half of the difference between the upper limit of one class and the lower limit of the next class. So in this case, since we do have, okay, 5, say for example, we have here our lower limit, which is 5 minus 4, and that will give us 1. So definitely half of it is 0.5. So 2 minus 0.5, this will give us our class boundary. Lower class boundary is 1.5 to 4 plus 0.5, so 4.5. So, isubtract lang po natin yung ating lower limit ng 0.5 sa, sa upper limit, mag-add naman tayo ng 0.5. So, this is 4.5 to 7.5. Then, 7.5 to 10.5. Then, 11.5 to 13.5. Then, 13.5 to 16.5. Then, 16.5 to 19.5. So, this is our class boundaries. Next step that we are going to do is to tally. We are going to tally how many scores belongs to the class interval 2 to 4, 5 to 7, 8 to 10, 11 to 13, 14 to 16, 17 to 19. So 2 to 3, 4. So in that case, so sa first, no, we have so 1, 2, 3. So we have 3. So in that case, we have 1, 2, 3. Next step that we are going to do is to look for the number of scores that belongs to 5, 6, and 7. So 5, 6, and 7. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. We have 1, 2, 3, 4, 5, 1, 2, 3. So next is to look for numbers that belongs to 8 to 10. So if we are going to scrutinize, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. So we have 14 numbers. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Next is we are going to look for numbers that belongs to 11, 12, and 13. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. So that's 18. So next is numbers that belongs to 14, 15, and 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then last is we are going to look for numbers that belongs to 17, 18, and 19. So we have 1, 2, 3, 4, 5, and 6. So we have 6, 2, 3, 4, 5, 6. So this is our tally of scores, guys, coming from this table. So we have to take note that this tally refers to the number of occurrences. That means that this is our frequency. So in that case, we have, when we look at the frequency, okay, so we have 3, then 9, 14, 18, then 10, and of course, 6. So this is our frequency. So if we are going to total the frequency, 3 plus 9 plus 14 plus 18 plus 10 plus 6, this will give us 60 now. So therefore, our number of observations is 60. So after tallying the scores, we are going to solve the class mark or midpoint of each class. So this time, what we're going to do is to compute the class mark or midpoint of each class. So in getting the class mark, we are going to add the lower and the upper class limit and then divide by 2. So 2 plus 4, then we have 6 divided by 2. This will give us 3. And then next, we have 5 plus 7. That is 12 divided by 2. This will give us 6. Next, 8 plus 10 divided by 2, 9. 11 plus 13, 24 divided by 2, 12. Then 14 plus 16, we have 30 divided by 2, 15. And then 19 plus 17, that is 36 divided by 2, 18. So that is our class mark. Again, in getting the class mark, we are going to add the upper and lower class limits and then divide by 2. Next is computation regarding the cumulative frequency distribution. The less than cumulative frequency distribution is obtained by adding frequencies successively from the lowest to the highest interval, while the more than cumulative frequency distribution is obtained by adding frequencies successively from the highest class interval to the lower class interval. So same sample, no? I will just copy the class interval here. So we have class interval. So we have 2 to 4, and then 5 to 7, 8 to 10, 11 to 13, 14 to 16, 17 to 9. Then I have to write down the frequency, katulad din kanina. So we have 3, 9, 14, 18, 10, and 6. No? So we have 3, we have 9, 14, 18, 10, and 6. Next thing that we are going to do is to compute for the less than cumulative frequency. So we have 3, no? Then we have to add 3 plus 9. This will give us 12. 12 plus 14. We have 26. Plus 18. We have 44. Plus 10. We have 54. Plus 6. We have 60. By the way, our number of observation is equals to 60. So we have here 60. And in looking into the more than cumulative frequency, so we are going to start dito sa baba na. So we have first na, we have 6. Then 6, we have to add it again to 8 to 10. So we have 16. And then 16 plus 18, that will give us 34. And then 34 plus 14, we have 48. And then 48 plus 9, we have 57. And 57 plus 3, we have 60. Okay, so this is our less than cumulative frequency, and this is our more than cumulative frequency. Again, this is being obtained by just adding frequencies successively from lowest to highest, while the more than cumulative frequency distribution is obtained by adding frequencies successively from highest class interval to the lower class interval. Next is the relative frequency distribution. The relative frequency distribution of a class is the frequency divided by the total frequency or total number of observation, and is generally expressed as percentage. So relative frequency is, again, the formula is relative frequency, or RF, is equals to frequency of its class interval divided by the total number of observations. So again, I will same sample kanina. So we have here our class interval 2 to 4, 5 to 7, 8 to 10, 11 to 13, 14 to 16, 17 to 19. And our frequency, we have 3, 9, 14, 18, 10, and 6. And our total number of observation is 60. So our relative frequency or RF, again, we can obtain our relative frequency distribution percentage by dividing the frequency of its class interval divided by the total number of observations. So we have here our calculator. So in finding the relative frequency, we have 3, na? 3, 9, 14, 18, 10, 6, no? A total of 60 number of observations. So we have 3 divided by 60. Okay, so our relative frequency here is for 3 is we have 0.05, then 9 divided by 60, so 0.15, and 14 divided by 60, we have 0.233, and then 18 divided by 60, we have 0.30, and 10 divided by 60, we have 0.167, and 6 divided by 60 is of course 0.10. So when we are going to look for the relative frequency percentage, RF percentage, so what we are going to do is just to times this, no? To multiply this relative frequency to 100. So say for example, so the first one here is 0.05 times 100. This will give us 5 now. So 5%. This is 5. This is 15. This is 23.3%. Then we have 30%, 16.7%, and then 10%. And in looking into the less than relative frequency percentage and the more than relative frequency percentage, almost the same din kanina, no? Ang pagbasihan naman natin ngayon is the relative frequency percentage. 5, no? 5 plus, okay, so we have 5 plus 15, 20, plus 23.3, that is 43.3, plus 30. So we have 73.3 plus 16.7. We have, okay, 90 plus 10, we have 100. So the more than relative frequency percentage, baliktad naman po siya. So mag-start tayo kay 10 plus 16.7 plus 30 plus 23.3 plus 15 plus 5. So we have 10, then 26.3 56.7 plus 30, that is 56.7 plus 23.33 is 80 plus 15, 95, and then plus 5, 100. So this is our relative frequency distribution. The percentage, the less than relative frequency distribution, and the more than relative frequency percentage. Next thing that we are going to show is the graphical representation of the frequency distribution table. So one of which that we could be able to attain out from the data, out from the given data set is a histogram. We can create a histogram regarding the frequency and the class boundaries, like in this particular example. By the way, a histogram consists of a set of rectangles having bases in the horizontal axis with centers on the class marks. The base width corresponds to the class size, and the height of the rectangles corresponds to the class frequencies. So this is our example. So another thing is we can also make a frequency for polygons. This can be done by plotting class frequencies against class marks and connecting the consecutive points by a straight line. And the last one is the ogive, which can be obtained by plotting the cumulative frequency by connecting the points of intersection between the class boundaries versus the cumulative frequencies less than or more than. So out of this visual representation, we could be able to interpret what would be the frequency distribution of the scores of the in the class based on the given data set. And of course, we could just easily understand, and we could be able to make sense of, we could just easily understand based on these figures. Before we end up this meeting, let me show you on how I actually uh, make this graphical representation using Excel. So I just actually utilize the cumulative frequency distribution as well as the frequency distribution table. So I have to put this one in Excel. So these are the things. Okay, so the first thing that we're going to do in Excel is to make a histogram, for the class boundaries and the frequency, then the frequency polygon, and the ogive, between the cumulative frequencies, more than cumulative frequency versus the less than cumulative frequency. So this would be the first, okay, the class boundary and the frequency. So what we are going to do is just to highlight the given data, and then let's go to insert, and then we can actually use the recommended chart or this one, insert statistic chart. So yeah, or we can have the tree map, okay, and so on and so forth. Pie chart, maps, pie scatter plot, and the pie chart. So in this case, I have to make use of the recommended chart. Then I'll move to all chart, no? Then histogram, this one, histogram, or you can recommended chart, then you can just simply click this one. There we go. This is our histogram. So in this histogram, I will just edit this one. So I will add an access title and a data level. This is the frequency and this is the class boundary. I can format the data series, no? So now this is our histogram, no? That's as easy as that. Next is the polygon, no? The frequency polygon. So we have in our frequency polygon now we are going to look for the plotting of the frequency against the class marks and the class boundary. So given we can go to insert and then pwede diretso sa scatter. No? So pwede rin kung sa dito tayo pili sa recommended chart. This is the same. This is the frequency and this is the class boundary. Ayan. There we go. This is our frequency polygon. Next is the ogive. So for ogive, we are going to plot the cumulative frequency now by connecting the points of intersection between the class boundaries versus the cumulative frequencies less than or more than. Again, puntang insert, pwedeng diretso sa scatter plot, or pwede sa recommended. So, purahin lang natin yung frequency kasi hindi naman kasali ito. Lagyan natin ng data level, frequency. Insert, lagyan natin ng data level. This is our class boundaries. This is our ogive. That's how we did it. So again, thank you very much for being with me this. Bye-bye, God bless.